So 5G features, standardization, and the status. So where we are at this point of time with release 15, 16, and what can expect in 15 and 16, we are going to talk about that. So quickly about the company, what solutions. Most of you already know about it, but if you are if you are attending maybe. So as a company, we already, covered around 100,000 plus students in the LTE since 2007 onwards, and around 1.4K students on the data-driven technologies for automation, artificial intelligence. We'll talk about a little bit later because that is a buzzword as far as the 5G is concerned. And around 75 plus employees globally across the globe as a company, as Award Solutions. And of course, one of the best companies to work for as far as the Texas state in US is concerned. And around 255 plus corporate clients across the globe we had so far, Award Solutions, and around 1,000 students on 5G itself, actually. So this is very interesting. And around 25,000 plus students on the virtualization. Again, the virtualization is the buzzword required for the 5G. 8%. So most of you, like you, probably the moment they attended any kind of programs of Award Solutions, they did definitely recommended for their colleagues or friends to take up some course. On an average, around 4.75 is SME rating out of a scale of 5. So now, as far as the training provider is concerned, what we do, right? So we are actually into the what actually required for the 5G. So you talk about artificial intelligence, machine learning, automation in telecom, which is very, very key and very interesting, and visualization of the data, and of course with Python Ensemble, and of course the data insights. So this is what most of the people may be knowing about it. So this is what typically required as far as the 5G is concerned. And it is not only that, we also do typically 5G and IoT, and of course CBRS specific to our US market, and of course 4G, VoLTE, etc. So quickly, so we'll see what are the different courses we offer. We have basically 3 levels: foundation, intermediate, and of course advanced, right? So that's typical what we do. So we have around 3.5 hours programs as far as the foundation is concerned, a little bit of intermediate with respect to some amount of e-learnings, but of course, which is very, very specific to a specific domain. So it could be signaling, it could be optimization, etc., etc. What we do that. And finally, we also do a lot of advanced programs. So with respect to the client's requirements, right? So we take even the logs from the clients, and we try to provide how to troubleshoot, how to optimize the typically your radio access network, our core network, etc., etc., right? So we do all kinds of interesting courses in the LTE, number one, number two, of course, optimization, and also, of course, our VoLTE, right? And of course, quickly, technical input. So we also talk in future how the voice would be on the 5G. That is on the pipeline. And as far as the 5G itself is concerned, again, we have the same 3 foundation, the intermediate and advanced programs, right? What I want you to focus is something interesting here. You can see the color. We talk something interesting way of learning is called the blended learning, right? So you can still be with your home, it can still be with your office, but still you spend maybe an hour or two in a day, still you could able to take up the courses that what we talk about self-paced blended learning. You have some courses like this with interaction with the SMEs, and as well as you need to work on a lot on your white papers, etc. And of course, hands-on sessions will be there. So that is the order of the day. So we are already there with it. So we have a RAN signaling or core network signaling kind of programs. It may stretch maybe for a month. So maybe once in every week. So you talk to the people, typically, people in the sense SMEs will provide the insights for that. And you go back and study and you do the exercise and come back maybe the next week, something like that. So that's what we do, the new buzzword at this point of time. And of course, similarly, we have the virtualization, right? So anything under SDN, NFV virtualization, including at to the level of your the workshops, we can do that, and we typically do that as well. And this is what I said. Please wait a minute. So this is the buzzword at this point of time. Everybody wants to know the moment you say 5G. 5G is not only telecom. So 5G, which typically boil down to a lot of machine learning, artificial intelligence, etc. So we do have a lot of interesting courses over there. We have artificial intelligence as a course, blockchain, and as well as augmented reality, virtual reality courses as well. Not only that, how do you visualize the data? So maybe the customer churn is one simple example I can give you, right? So typically we talk about data visualization with respect to, of course, Power BI, and of course we can also do with respect to Python, etc. All the interesting courses which is typically required for your 5G network, right? And I need your attention, gentlemen. So please, note this. So whoever would like to take the program. So this particular code is valid up to October 31st. So there is going to be a program, interesting program, right? So 5G radio technologies and deployment program starts on 4th November. And I'll spend more few seconds or here. Starts on 4th November, and this is the webinar code, right? So http://bit.ly/2vkhnci. Right, so this is typically what you can save around 40%. So I encourage all of you, just use this code and visit our solutions website for the insight, and please take this opportunity, right? So thanks in advance for your business. So as I told you, for anything, so you can just visit the website awardsolutions.com, or you can just put an email saying that info@awardsolutions.com. Either way you can do it, but still I encourage all of you, just visit the Award Solutions website to get more and more insights about the training, what new things is coming up in the industry. So being this is web-based training, so thanks in advance for not taking audiography, photography, or videography, right? So which is not authorized. Thanks in advance. Thanks for your cooperation. So about me in brief, so I spent 18 plus years only in the wireless telecom. So mainly into operation, maintenance, and training delivery, mostly towards the radio access network. Of course, a bit of core network as well. And my instruction focus would be into the over a period of time evolved close to 18 plus years. So 2G, 3G, 4G, a bit of WiMAX, 5G, RAN. Of course, maybe after a couple of years, if you talk to me, maybe I'll be in 6G as well. So that's what in brief about me. Okay, so let's come back. This is where I need your attention. So we are going to talk about the actual, the program for the day, right? So we are talking about performance requirements for 5G, right? So what is actually we would like to have as far as the 5G is concerned, right? So then what are the different organizations responsible? Some of you may be already knowing about it, but still we'll get into the details. Who is actually responsible to lay down the specifications as far as the 5G is concerned, right? Then what are the building blocks of? So we have building blocks for 4G. Similarly, is the building block as far as the 5G is concerned, right? And we'll see the NGMN, Next Generation Mobile Network Alliance. What is their role basically, right? So there is actually these particular people will play a very important role in every technology. Similarly, so they do have a very important role to define how the 5G would be, how the 5G should be, right? For as a network, as a specifications typically talk about, right? That's what it is. And of course, what would be the roadmap for 5G? So what is there in next few years, right? So release 15, release 16, and what is they are expecting to have it basically. And finally, we talk about HC and ONF for standardization, particularly toward the core network. And finally, what are the terminology and by which organization. So this is in brief about, this is close to around 35 minutes to 45 minutes of delivery. Let's get into the actual course. Now, next generation mobile network contribution to 5G is very important, very interesting. So what actually they want, right? So these people are very interesting. They never talk about as in solo. So they always talk about, for example, say end-to-end ecosystem, right? So this ecosystem is very interesting word because we don't want simply shut down one technology because we are moving to 5G, right? We always want to coexist as much as possible unless until it is a particular technology will become an obsolete. You see, if you look example, still we are using it, right? It's almost close to 30-year-old. So that's where your ecosystem typically will come into the picture. and fully mobile and connected society. So we are not going to talk anymore as a connected network. So we are talking about societies are connected. The word itself is very interesting. That the moment you say society, which includes everything, right? So that 5G enables that. How I will say a little bit later. The moment you say society, so we are not living any more in solo, right? So the telecom world, particularly in 5G, is more little bit differently the way earlier we had, right? So today we talk about all the vertical markets is the or we are trying to combine with us and we help them to provide their connectivity. So that's how this society word is very very important comes into the picture. Value creation, customers and partners, fine. Emerging use cases, this is what is very very important, interesting, right? So we talk about the medical applications, IoT applications, smart cities, smart grid. You can have a huge amount of the list, but yeah, the idea is new interesting use cases are coming into the picture, right? And this is important always. I always keep telling in my classes, quality of experience is the key word today, right? We don't limit ourselves anymore with the quality of service anymore. So we are referring to quality of experience. Experience means basically the user experience. So how the user is experiencing with the network, right? So what best experience you could give with the 5G network, right? So enabling end-to-end networks, right? So that's what typically we do. Of course, obviously we need the business because we need money, right? Finally, at the end of the day. But this what the interesting statement as far as the you can say the vision, right? As far as the NGMN is concerned, as far as the 5G network is concerned, right? So with this, let us go further. Still, I encourage if you really have any questions, you can just put in the chat window. I'll take them up. Otherwise, we'll go further. So now what is actually changing at this point of time is this. So we know there is a broadband access, right? So that is okay, not an issue at all. But how it change, right? So the moment you say video and photo sharing in stadiums, so this is where your Olympics are coming up, right? So Olympics 2020, Tokyo Olympics 2020, they are going to put up the first commercial launch of 5G network. Invariably, they are going to do a lot of interesting things with that, right? And extreme real-time communication. So here the extreme real time. So real time, this is where you talk about your latency basically, right? So the latency will be which order of less than a millisecond or even less than that. But of course, we have to see how it goes. But that is the idea, right? So remote robotic control, remote surgeries they are talking about. 5G is concerned. And this is what going to happen a lot, huge amount of devices. You think of anything at home, maybe 5 years down the line, at least all your electronic gadgets, probably at least 5 to 10, at least a small home or 20, probably would get connected or communicating to people. That is a bomb happen. So having said that, how many devices you can as a 5G network can support, right? And of course, obviously, at the cell edge, this is very important, right? As a cell or operator, we worked technically a lot. At the cell is always a challenge, right? So we evolved over a period of time from 2G, 3G, 4G, 5G. So at the cell edge, typically we try to give around 50 Mbps, right? Even at the cell edge. That is the basic idea. So with this changing world component, so what is happening is this, right? So high speed trains. So today the trains are moving even, right? So nothing less than say 200. But if you go and see China and Japan and France for particularly, so they may move around 500 kilometers per hour. But still, can they provide connectivity? Answer is yes. That's what typically we talk about, right? So 3D aircraft and drone connectivity. So there is something called your drone computing is coming a lot, right? So there is also internet can move for a particular path. And ultra reliable, this is a very interesting word. So what do you mean by ultra reliability? The packet loss, right? I'll say simply loss can be 10 power of minus 3. No, it could be 10 power of minus 12 or 10 power of minus 6. That is the order. 10 power of minus 3 is already point of time. But I want even much better. So that's where you talk about 10 power minus 12 or 10 power minus 6. That's where your ultra reliability comes into the picture. Then we can definitely can do remote surgeries with robotics, right? So that's what future would be. And of course, the broadcast is always there, but yeah, we can have a better throughputs. Now, obviously, any technology should always help the a human life. So that what typically we try to do it, right? We finally. So now when you talk about NGML, so 5G is concerned, so one is user experience, that what I already told you. What is user experience typically? So user data and of course latency. Latency already we talked about, around less than a millisecond, right? User data, you see always in my language I used to say dil mange more. That means I want always more and more and more. So what is that basically? So it boils down to, so maybe gigabits per second, right? So we are moving away from megabits per second to the gigabits per second, right? Maybe 1 GB, 2 GB, and maybe order of 20 GB. That's what we talk about. So obviously I'll feel better, right? Then we talk about interesting business models. So we'll see the vertical markets are opening up. So actually people say we cannot think at this point of time what could be the business model. That's how the three simple triangles has been opened up the huge amount of the business. And enhanced services, that's what I said. So now this is interesting. So system performance is very well. So key performance indicators, we all lived with that, KPIs, right? So now, but here the KPI is a little bit different, because we talk about how many devices can be connected per square area. Typically that is nothing but a square kilometer. The people are talking about around 100,000 devices per square kilometer should be get connected to the 5G network, and they should able to communicate. So that is how it is going to happen. And obviously any technology evolution is basically for your spectral efficiency, right? So that what typically we boil down to. So spectral efficiency should be much around 3 to 10 times better than the existing 4G network, that what typically they are referring with. And this is very, very interesting and very crucial, very specific to 5G. What do you mean by that? Flexible, scalable network. So that itself is one word we can talk maybe hours together. But anyway, so the idea is, can I scale up and scale down the based on my requirement at any given point of time? Yes, that's where your 5G is talking about, right? Similarly, the management and operations as simple as possible. So typically we talk about, right, the capacity OPEX reduction, right? So the capital expenditure and operational expenditure is supposed to be as minimal as possible, right? So that's what the 5G, particularly the core network, they did a lot of interesting changes. We'll see a little bit later, but that is where you talk about the flexible, scalable, and efficient network. At any point of time, I can scale up. At any point of time, I can scale down and use the resources as optimal as possible. So far it was not addressed in the industry up to at least 4G, right? So that's where the keyword comes into the picture. And of course, over the air configurable and power efficiency, because we are talking about so much networking and so much throughput, so obviously power efficient is always mandatory. So this is also, we can add a lot of interesting things for that. There is something called the green telecom is coming up. So green telecom means unless otherwise I will never radiate station perspective. Unless until I need to receive or transmit, my handset will typically get onto. Of course, up to certain extent, we know DTX, DRX, but it is more relevant and more crucial in the case of 5G network. And configure anything, whatever I want over there. So that's what going to want happen, right? So that's what typically. So now let us see the roadmap. So most of you already know about it, but I would like to spend, I would like to spend on the rightmost 2 points basically, because we already evolved, right? So release 99 to whatever, release 8, typical LTE started, release 9, 10, 11, etc. And of course, what is more relevant for the today's discussion is these two green boxes on the rightmost, that is release 15, right? So that is where our 5G specifications typically comes into the picture, right? So having said that, so we'll see what actually we want in the 5G typically. So in the 5G, we say the peak data rate around 20 GPS in the downlink, and obviously uplink always low requirement, or also handset requirements, battery power requirement, etc. 10 Gbps. And latency, as I already told you, around less than a millisecond, and number of devices, as I told you, this is where we talk about IoT, massive mission application, MMTC, etc. all going to come into that domain, that where we talk about around 100,000 devices per square kilometer, whatever. Right, and cell throughput and 100 Mbps per square meter. You see that now how we are going to define these KPIs are going to change. So in the 5G, if somebody is want to do optimization, so there are new KPIs going to come up into the picture, which was not thought about in the case of 4G because of two basic reasons. One is the latency requirement, next is the number of devices, etc. And obviously, of course, at the cell edge data rate around 100 Mbps to 50 Mbps. So these are the performance targets. So as we know, right? So performance targets always excellent, but obviously because of various reasons, so at least you should be able to achieve, right? At least 80% or 70% of these targets, whatever we put it, right? So now this is what your ITU comes into the picture. So IMT 2020 rather. So spectral efficiency, as I already told you 3 times, mobility around 500 kilometers, etc., which we already talked about. So peak data rate is around 20 Gbps, experience around 100 Mbps data rate. And this is what I said, which is very new. I'll write here new KPI going to be. And energy efficiency is also new. We never talk about it. If at all somebody would like to see what is new KPIs for the 5G could be, right? So this is what a few things, right? And of course, connectivity density is also going to be a new KPIs, as which was never thought about up to 4G at least, right? So now this is what in future would be. Of course, latency, we had a lot of things, but of course, latency would be around less than a millisecond typically. So that's what we try to achieve it. So anyway, this is what the performance goals for IMT 2020, and we'll see how the network to enable this, how the network is going to change, right? That's what network architecture. So all of us know basically two parts. So there is no third part basically. So we have the RAN part invariably, and we have the core network part, right? So this is as simple as that. You take any telecom network right from the GSM, we could do the same thing, no change in that, right? So, but what is fundamental key change in the case of 5G would be is something like this. Common interface towards 5GC, that's fine. Support for network slicing. So this is what very important. Whenever we talk about the vertical market support, then the network has to be sliced, right? So slicing is not very blind. The slicing will be done based on a basic quality of service. When it comes to the core network, right, that what we saw in the previous slide, independent scalability. This is very important. So, and flexible deployments. Today I want more capacity, I will put it. For example, I already gave you example of say Olympics 2020 in Tokyo, right? So next year around July, August time frame. So only for say 2 weeks or maximum 3 weeks, they need huge amount of capacity. After that, nobody will be there in the stadium. So I just scale up and then immediately scale down, right? So that's what typically we talk about. And whatever the flexibility in terms of what actually, let me put a word here. The flexibility in terms of introducing the new services to the subscribers or the customers at any given point of time. If you look at today, so if I want to introduce a new service, invariably that takes nothing less than 6 months to a year or 2 years sometimes, because I have to do a lot of testing, right? So now all those things, the time to introduce a particular new service or an app or application to the subscriber would be very minimal. So that's what typically boil down to. Quickly, let me talk about the another part. So this is your user plane function. This is only user plane packets would go for the subscriber to the data network, and session management function, and UDM, this is equivalent of your HSS or HLR in the case of 3G and 4G, and authentication support functions here, and of course access and mobility management functions. So this is very interesting. So because without mobility, so there is no mobile networks, right? So who does the mobility management? Typically AMF does. So that is equivalent of your MME. But here you could see very clearly, so this is signaling and the traffic, or the signaling plane and the traffic plane, or the user plane. So one of the key features of the 5G is cups, we say, right? So it is not actually teacups. Of course, you can enjoy a cup of tea, but the idea is the separation of the control plane and the user plane. So that is very key and interesting philosophy as far as the 5G is concerned. So that means none of the user plane packet will touch any point of time to the control plane network element at all. So that's how the whole network has been designed. So that is a very interesting part of the 5G network. So this is what typically can happen. Of course, the new name for the same node B is nothing but a G node B. E node B, we know it is coming from the LTE, but here we call the G node B, right? So of course, collection of G node Bs is nothing but the radio access network as far as the 5G is concerned. And of course, we have something called the 5G NR, that is nothing but the new radio as far as the 5G is concerned. So features matter. I want your attention here. So very interesting. Most of you, I'm sure, would be interested in this. So what is happening, right? So we talk about release 5 and release typically. And this is also called phase 1 and phase 2. Phase 1 is release 15, phase 2 will be release 16. Simple as that. Now, what is interesting thing in the is service-based architecture. We'll see a little bit later, but that's what typically the complete 5G network is. I'm saying that, okay, I'm providing a specific service. That's where you have your service-based architecture comes into the picture. And a new radio, as far as the radio access network is concerned. And of course, just now we talked about network is sliced. So end-to-end network. So here, there are three things you should think. What do you mean by end-to-end? We have the radio access network, we have the transport, we have the core network. All the resources would be sliced for a specific kind of application or a domain of service with a specific quality of service. That's what typically we do. And as close as possible to the subscriber, multi-access edge computing, we say, right? So some, of course, non-telecom people is also considered as the fog computing, but here we don't use the word fog computing, but we say MEC computing or the multi-access edge computing. Edge means as close as possible to the subscriber typically, or as close as possible to the G node B, so that I can take the packets and push it across. So these are all the things what actually they define. And I basically expose, hey, come on here, I'm a 5G network, I can do ABCD services, something like that. That's what we talk about, the network capability exposing to the third party. It could be WiMAX network, it could be 3GPP2 network, it could be 3GPP network, it could be Wi-Fi network, doesn't matter, whatever, right? Any vertical market. But hey, come on here, this is what my capabilities would be. So based on that, you make a request, then I provide a service. Similarly, of course, separate session mobility management. Just now we have seen, right? CUPs will come into the picture and better quality of service. And of course, still we do interwork because just we can't jump directly, right? So still we do interwork with your EPs. This is what release 15 spec has been frozen, most of them. What you can expect in release 16 is something like this, right? So NOMA. So totally a new interesting multiple access technique is going to come up. So we have to wait and see how this is going to impact on the network, but still they are going to work on that. Still the spec is not at all frozen. And a lot of V2X going to happen, right? A little bit has been definitely defined, but a lot of interesting things are going to come up where your connected car will be part of that. And what is going to happen in the release 16 is non-terrestrial network. So what the Utron, if you see Utron, UMTS terrestrial radio access network, that is only on the surface of the earth, right? Or the ground. But now you can talk to the, the satellite, and just satellite can be a backhaul. That's what people say. Or the backbone, typically. That's what people are going to talk about. We have to wait and see. And of course, unlicensed is always interesting for us. So whenever I need, I just take the help of my Wi-Fi or any unlicensed band in all the three bands, so I can use it. So this is what is going to happen in the 15 and the 16. Okay, fine. So most of the phase 1 we talked about 15, and phase 2 would be the 16. So that is Q1 2020. That is maybe next 9 months down the line. They're typically planning to freeze or the release 16 specifications. The same thing here, deployment, obviously, as I told you. So first definite commercial deployment, which can be actively can be seen, is by the Tokyo Olympics 2020. Okay, that's what you can read from bottom to top. So commercial system ready by 2020, standards ready by, of course, more now. Some of them definitely are ready by 2018. Okay, now from now onwards, we had some introduction. Now onwards, we take about how the radio access network, how the core network, how MEC, how slicing has been defined. So as far as the 5G is concerned, that would be the focus for next 20 to 30 minutes. Still, I encourage, if you have any questions, maybe you can just put in the chat window. And quickly, just all of you can give me a green tick so that could hear me and see the screen quickly. I appreciate. Give me, all of you can give me a green tick. Because this being a webinar, so I would like to know that you, at least you should able to hear me. You could hear me. You can just give me a green tick, all of you. Okay. Thank you very much, Dennis. Okay, so let's go ahead. So we have to cover it quite a bit. So now, what is there in the 5G NR typically, right, at this point of time? So who is the standardization body? That is the actual purpose of this particular program. So the 3GPP, right, most of you know, so third generation partnership project, right? So actually they defined the complete protocol stack enhancements from the existing the LTE at this point of time. Right, so it could be dual RRC, very interesting concept. It could be ENDC, and of course MRDC, multi-RAT, dual connectivity, and of course ENDC, E for UTRA, N for NR, that is 5G. So 5G and 4G LTE coexistence, that's what dual connectivity. So these specifications are coming from the 3GPP, and ITU actually defined, obviously, right? So WRC basically, that is what which band can be used for what, right? So we have the sub 6 gigahertz, and also you have your 24 gigahertz. So quickly, somebody is attending for the first time at 5G. So we have something called your FR1, and we have the FR2, frequency range 1 and the frequency range 2. Frequency range invariably typically below 6 gigahertz, and frequency range 2 would be starting from say 24 gigahertz and can go up to 100 gigahertz. So this has been defined by ITU. And massive MIMO, so 8x8 MIMO, so 4x4 and 2x2 is already there, and we know that it is already implemented by the networks in the up to 5G, right? So that is now it can go up to 8x8 MIMO, and as well as the beamforming is typically possible. Now, so this is very interesting. Flexible frame structure and numerology, right? So you know that there is only 15 kilohertz subcarrier spacing as far as the LTE is concerned. But now the subcarrier spacing is changing. Means it is variable. Means what, I can have 30 kilohertz subcarrier spacing, 60, 120, 240, and 480, right? So as the subcarrier spacing increasing, because delta F and delta T is a constant, so the time required would change. So that's what you talk about your enhanced multiplexing basically. Means when you talk about remote surgeries or the remote robot-based surgeries, when we said, right, so industrial 4.0, for example, industrial IoT, where the delay has to be as low as possible, how can I do it? I have to have the better, higher the subcarrier spacing, obviously time would be less. So the symbol time will be less. So that's how we have your enhanced multiplexing. So this is who is responsible for all these things, basically your 3GPP standards coming from the 3GPP. And quickly, so what actually happening at the RAN side is something like this. We have your, this all we know, which is already there in your core network of LTE. So we move to something called your BabyU pool or baseband unit, which will have the physical MAC and of course your RRC. And what we could do is split G node by architecture. This is what very interesting thing can happen. Splitting, we are going to do it. But the splitting is not blindly we do it, where we do very logically. So that's where we have your, you can see here. So physical layer and RLC MAC into your distributed unit, and the central unit will be your the actual PDCP and RRC still at the part of the GNOB. I mean CU or central unit, and this invariably connected with your eCPRI or Ethernet mid-haul, right? So that I can have less latency, right, compared with the existing LTE network. So that is what going to happen. So this is one of the interesting change is going to be considered as far as the 5G RAN is concerned. So now quickly, there is something called cloud RAN. So can I put on the cloud? Obviously, anything if you talk about a software, I can put it in the cloud, unless until it is a typical antenna hardware. That anyway, we cannot do it. But that's where you have, if you look at here, so the functionality, for example, MAC layer and PDCP RRC is basically a set of code, right? Maybe a huge amount of the code. So that can be, instead of having your own hardware, I can just segregate that and I can put onto the cloud basically. That's where your centralized BBUs comes into the picture. And of course, I can do your virtualization as well. So once I can centralize it, it's basically because it's just a cloud. I mean, the software code, I can put it into the cloud and I can just interact with it and pull a small code and just push it to the hardware and it will work. So that's what typically it can be done. So obviously, your radio unit H and remote radio units or remote radio heads, whatever you think about. You can see here few miles. Typically, they are thinking about around 10 to 25 kilometers. Of course, there are certain limitations are there, but still you could achieve so much. And who is responsible for that? It is the, I mean, the for our course for today is again CIPRI. CIPRI specifications are responsible for the definitions, right? So there is something called CIPRI, there is something called the CIPRI, enhanced CIPRI, which can also sit on your the Ethernet typically, right? So on IP. So that is what we could do it. And of course, most of you already know about it, WOPSI, HCORI. And this is, I want your attention over here. There is something called your Open RAN coming up. Very, very beautiful philosophy. So everything is open. So the all RAN, it could be any vendor, it could be any software, it could be any technology. It doesn't matter, but still I could provide with respect to my machine learning and automation, things like that. So this is what, if you talk to me, maybe after years, probably we would be talking only on the Open RAN. How can I do it? There are a lot of interesting things already happening it, but I mean, actual component, working component, maybe you can see maybe within a year or two. So quickly, so what is there in 5G layer 3 specification, the process of standardization? Of course, the RRC is very interesting, right? Most of you know about it, right? So RRC typically 36.331 or now 38.331 as far as the 5G NR is concerned. So there's a lot of evolution is happening, but still a lot of good interesting content is already there. And of course, NR, how the NR should be. There is something called light NR. We have to wait and see how it can happen. And the new spectrum bands, right? So maybe even we talk about less than 6 gigahertz, but now it's already 7.12 gigahertz is already kind of decided. And maybe in the next version, they should freeze it, right? And of course, MAC, RLC, and PDCP, particularly when you talk about your SA and NSA options, how the delay can happen, when they are also talking about dynamic spectrum sharing and all those things, something has to be modified, but more or less it is being done. And not to support OFDM based multiple access still today, so still it is a legacy OFDM based system. It is not going to change anymore. Flexible TTA format, structure defined by 3GPP, and of course, massive MIMO is already told you, right? So 8x8 at this point of time. So we talked about RAN, what is there in the core network. So this is what I already told you. Let us start from here. So of course, most of them are 3GPP except your NFV. So, but SBA, service-based architecture. I'll give a small example here before I go further. So most of you are already using, say, Ola cabs or Uber cabs, right? So what actually that company does? The company actually provides a platform for you as a customer and as a cab driver. So it's, if you look at the business perspective, it's called the platform type of business. But here in the 5G also, what we try to do is, I'm say that, okay, this is what service would be. Now, what is the service? Telecom service, basically. So telecom means what here? It could be, say, MME functionality as far as LTE. But of course, when you go to your, it could be UPF, it could be SMF, right? It could be MF functionalities, simple. So all put together, I'll say I provide, say, EMBB service or URLLC service or say MMTC service or remote surgery service. So that's what typically service-based architecture would be. Very interesting and very important. And I already talked about it. So CUPS, control and user plane segregation or the separation is order of the day and it's very key to 5G network. And of course, this will talk about the modular here. And of course, network functionals are exposed. I already told you, right? What I can do, you can book a cab, for example. When you visit, say, Ola or Uber, what is that actually you could do? You can basically, is they say that, okay, I can provide a cab service within Bangalore, maybe within a city or outside the city, etc. Right? So similarly, I can provide ABCD services, simple. Right? But what network exposure function as far as the 5G core network is concerned. So what actually where we are at point of time? SB is more or less completely defined. User pen is also defined. Cups separation is defined, and where you can do your virtualization of those things is already being done. And very interesting. So how the cost has to be measured. So now all of you know, if you look at your say UMTS, so we have only 4 quality of service classes. LTE we have 9 quality of service classes. If you come to 5G, we have around 255 plus they are about to define. Already they are defined around 50 plus different quality of service classes. So why required? Because we talk about EMBB and slicing, etc., etc. Right? Interworking is already there with the LTE, not with 2G, 3G, but with LTE we do have it. And so how do you register with the 5G network? And quickly, of course, let me not get into this, but yeah, we could do your virtualization. Once you do virtualization and software defined networking always go together. But I want your focus is here. We'll spend maybe few seconds here. Very, very interesting concept. We talk about a network slicing, right? So I'm going to slice it. So apple a day, keep doctor away, fine. But when you do slicing, the idea is not to provide the same taste, right? If you look at any slice of apple, you will get the same taste. But that is not the point of that is not the aim of your network slicing. The aim of network slicing is every slice should get a different quality of service. I'll write quality of service. Actually, it is going to be a quality of experience basically to the subscriber. That is the basic idea. It could be EMBB, it could be connected car, it could be remote, whatever you can think of. It could be only or 5G in future. All things are possible, but that is the basic idea, right? So that's what we say. Segment the RAN, core, and transport all put together is what we typically do, right? It could be one services or it could be multiple services possible. And obviously we talk about life cycle. So when you start a slice, when you stop a slice, how long you want to provide a service, etc., is nothing but your life cycle management for a specific slice, because the network resources at the end of the day is X, that is constant. But within that only you typically try to do some amount of slicing based on the need and requirement at any given point of time to the customer and make the customer happy. That is the idea. So that's what we said, right? I explained already there here. So it could be, for example, say a connected car, right? Service. It could be IoT. One slice can be IoT. One slice could be all your browsing and streaming applications, etc., etc. So you have the same network resources and you slice across the RAN number 1, transport number 2, and of course core network number 3, and provide MBB service basically. So what you could do here, so as I already told you, so you can see here the color. If you want to map the color is same color here, for example, right? So what provide the service in the RAN network should be mapped onto the core network and also should be mapped over the transport here. So that is the key interesting thing. And finally, you also should have, of course, this already defined by your HC standards, communication service management typically, right? Network slice management and subnet, etc., etc. When to start a slice, when to stop a slice, what is the quality of service you can configure, how much you can configure. This is all basically the management part of it. So this is where your lot of analytics comes into the picture basically. And what is there in the slicing? Most of the things has been defined as far as the slicing is concerned. Of course, they may expect more and clarity with respect to V2X and terrestrial network for the slicing. But at this point of time, most of the things have been defined up to certain extent. And the third point for this course today is multiple access edge computing. As I already told you, it's also known as fog computing for not non-telecom people. But for telecom people, we don't say it's fog. But you see what is the difference between cloud and fog? Immediately you can say cloud is always too far, right? Somewhere in the sky. But fog is very close to us. So that's what typically. So now why we do that basically? So in the place of fog, we'll say edge. So edge of the network, if you see, is nothing but your the RAN network or your G node B in the case of 5G or E node B in the case of LTE. So what we do is we have something called your multi-access edge servers, right? So basically, for example, tomorrow if you have Netflix streaming video applications, if I want, and I don't want to have a huge amount of the delay, and I don't want across a particular city, that is wasting the resources. What can I do? I take a set of Gnode Bs and just I put my MEC server over there and just push the data over there. So multiple access means here how you can access. You could access typically maybe with respect to Wi-Fi. It could be 5G. It could be LTE. It could be any kind of short range wireless networks at this point of time, whatever the 5G supports. So it could be any access. It doesn't matter, that multiple access, right? And also multiple kind of applications you can think of. You can see here it could be for connected car, it could be a surveillance, for example, or it could be ATM, or it could be a basic streaming Netflix kind of application. Anything is still possible, right? So now let us see, as far as the standards perspective, having understood what is MEC. So typically, of course, HC is one of the key standards who actually defined architecture, how the virtualization can happen, etc. And of course, NGMN, always, as I told you, right? This is a very interesting company. So they already say this is what the vision would be. This is how the MEC should work, typical. That's where they define. And if you want, maybe these are all the three specification bodies, HC and 3GPP, obviously. Of course, you can check in the 3GPP specifications. They already defined some MEC kind of specifications for us. Where is the standards perspective where we stand at this point of time? So already defined 3GPP supports whatever HC says architecture wise. So 3GPP generally accepts it. This time also we accepted it. Then how do you establish a session? This is very, very interesting. There's something called the local LAN, basically. So that's where you are. Best example I can quote is your Netflix, for example. As close possible to your say home, I provide a MEC service and push your Netflix streaming video, something like that, right? So management, how can you manage it? Where is your IP network? How many sessions you can establish? What is your IP mapping? These are all going to be some of the stands, but yeah, this is more or less standardized at this point of time. And what is we are going to put together? So we talked about RAN, we talked about the core network, then we the MEC and the slicing. There are basically four components. If I write here, one is your radio access network. Second thing is your core network. Third is your slicing. And fourth is basically your MEC, right? So these are all the 4 or 5 typical 4 interesting domains we can think of, or points we can think of. Now, who is responsible at what level, right? So obviously it has to be end-to-end, right? So, and first slide we saw, right? NGMN is basically end-to-end network. So you can read this slide, whatever you can see on the screen, either the way, maybe from top to toe or bottom to top, doesn't matter. So generally, if you look at say bottommost one, next generation core network, right? It is basically, let me write, what is the power of your the next generation core network? Basically starts with your SBA, right? Service based architecture. This is very, very important. This includes, it's a service architecture. This is enabling capex opex reduction, and your whenever you want, you can increase the network resources. Whenever you want, you can decrease the network resources, right? Scalability, typical. I put in a different word, but basically scalability can be done much easier and easy way. And it's mostly nowadays are software driven. So microservices, all those things will be part of that. And obviously 3GPP has done that further. I mean, today's discussion. Now, network has to be virtualized. So we talk about network functions virtualization. All the functions are virtualized. There is nothing called tight binding between hardware and software. Those days already gone, right? So that's where your ITSI defined how it can be done. There are multiple ways to do your virtualization. Of course, up to a certain extent, it was implemented in LTE. More to do with your in the case of 5G network, because once you do more and more of virtualization, it is easy to implement your SBA, service based architecture. So that's how these two will always go together. They can't be independent. And having said that, so this was always a bottleneck for us. So the third level is the cups. That's what control plane and user plane separation or the segregation. So if you look at MME, for example, or if you look at particularly SGSN kind of network elements in the previous networks, so control plane information, user plane information used to go with the same box physically. So then obviously they would offer the delays, right? So we all know, right? So control plane delay and the user plane delay definitely is not the same, right? Because of various reasons and requirements. So how can I manage it better? Because user plane delay has to be as low as possible. Control plane delay is still okay, doesn't matter, right? But how can you manage it? That's where you are. The control plane, user plane segregation comes into the picture. When you do a software defined networking, I can manage both of them very interestingly and very efficiently. That's where your IETF, ONF actually comes into the picture. Having done all of them, so then what is very key to 5G? Oh, okay, very interesting and very important point is slice it. So you in the morning, don't know, so maybe you enjoy your bread, right? So if you take a fruit bread, for example, right? So obviously every slice will have a different cherry pieces. Sometimes you may not get. That's what nothing but your the quality of experience and quality of service. So that's where your network slicing comes into the picture. Again, all the three bodies are responsible for that. 3GPP, HC, and NFV all put together, they did define your the network slicing. Remember, network slicing is basically your end-to-end, right? So when I say end-to-end, that includes RAN, number one, that includes your transport. I'm writing on the slide, plus core network as well. Right, all the three put together is where the slicing comes in picture. Otherwise, how can I provide my quality of service or quality of experience? It doesn't work, right? That's where we talk about network slicing is always end to end. That includes all the three basic components: radio access network, transport network, and the core network. Now, having said that, excellent, fine. But when you talk about the application per se, right? What is the kind of application you can give it to the subscriber? Is nothing but how can I make subscriber happy? Is nothing but your the multi-access edge computing at the edge. So as close as possible to the subscriber means as close as possible to my GNODB. I should have the MEC server and I can have some amount of the data. Best example is Netflix streaming video, for example. I push it so that delay can be minimal, right? So that's where your MEC comes into the picture, right? So, but to enable all of them, what is required at the radio side? Invariably, I need a new radio altogether, right? So that's what very interestingly they gave the name called a new radio. Right. So here the radio, what is fundamental difference is we had MIMO, we had beamforming. It is very to your 5G is your we call a numerology, right? So some of you maybe believe in numerology astrology, right? Something similar to that here. So we have the subcarrier spacing SCS, all right, 15 kilohertz. Not only 15 kilohertz, it could be 30, it could be 60, it could be 120, it could be 240, it could be 40. Right? So this is my subcarrier spacing. So as you increase the subcarrier spacing, we all know, right? Arithmetic. So the time taken, the your symbol time would be minimized, right? So that's where your new radio is more to do with it. And of course, one more key feature of the new radio is also we have the frequencies less than 6 gigahertz and also from 24 to 100 gigahertz, right? So that's where the whole philosophy comes into the picture. Now, all these three things put together, if you observe carefully, who are all actually responsible for the overall specifications, right? So number one is your 3GPP. Number two is your HC, of course, right? Number will be your ONF. And of course, number four will be your CIPRI bodies. And of course, how can I forget? Number one is NGMN, right? Next generation mobile network, organization. So these are all the typical bodies, but invariably most of the things already been specified in the 3GPP specifications. But I can quickly tell you if somebody is interested. So please refer 38.x series and 37.x series, right? And apart from your 22, 23, 24 series, right? So 38 and 37 are very, very new as far as the 5G is concerned. Okay, so that's all technically from my side. Any questions you can just chat, I can answer it. Before you answer it, you ask for a question. So again, just quickly, there is a 5G curriculum all of you to just visit awardsolutions.com for more details for any trainings, right? And you can also send an email to info@awardsolutions.com for any more information. So we are happy to help you and reply back on your email, right? So any questions so far? So anyway, let me articulate the essence of this program is, so what is actually happening in 5G? Release 15 and release 16 as far as releases are concerned, number one. Number two, who are all the basic specification bodies are actually involved in that? I already wrote on the slide, but let me repeat it. One is, of course, 3GPP, and of course, NGMN, and of course, your HC, right? So these are all the three main, of course, ONF and CIPRI as far as the cabling is concerned. So there are all the 3 or 4 bodies are which was very, very relevant and important bodies who are taking part and very seriously they're defining the specifications. And if somebody is interested for the new radio, just they can refer 38 series, and as well as mix between both of them is nothing but 37 series. You will find if somebody know 36.331 for RRC, you can just refer 38.331. Exactly in NR new radio, what happens, you will find there, right? So that is, and of course, quickly, if I map onto the main components or the philosophies as far as the 5G is concerned is, CUPS is your control plane user plane separation or segregation. And of course, your network slicing, and SBA, service-based architecture, and of course, MEC, basically mobile edge computing, which is equivalent of fog, but we in telecom world we don't say fog. And finally, the radio has to be very, very important for most of you if you are coming from the radio perspective, right? So the new radio, right? Fundamental change is the numerology, right? That is, we still support 15 kilohertz, but we also support 30, 60, 120, 240, and 480 subcarriers, which we have a lot of time-sensitive applications can be used or can be implemented with the 5G. So 5G is basically for the vertical market. We have seen the new radio, right? So where we have the frequency ranges less than, also known as sub 6 gigahertz, and also from 24 to 100 gigahertz, they already defined varieties of bands for capacity and coverage. So that's all from my side. I'm just thank in advance. So thanks for your participation for all of you. And maybe still you have any questions you can put in the chat window. But still, otherwise, thank you very much for your participation. Have a nice day. And hope to see you in some other programs, maybe webinars like this or any other training programs. Okay, so 1 minute. So quickly, I will project this slide for you. This is for you that you can use this promo code to get around 40% off for the next program.